Hello students. In this continuation of our video series, I have come up with the topic liquid solution. In the previous video of liquid solution, we have discussed about vapor pressure, we have discussed about solution, and we discussed how vapor pressure changes if we change the temperature or if we add non-volatile solute in it. Okay, this much we understood. Now in this video, I am going to describe a law called Raoult's law. What it actually does, let me ask you a very simple question. Suppose I have a solution in which I have a volatile solvent and I have a non-volatile solute. Okay, if I increase the amount of non-volatile solute, what do you expect? If I increase the amount of non-volatile solute, so do you understand? More non-volatile solute means more coverage of surface area. More coverage of surface area means less vapor formation. Less vapor formation means you will get to see less vapor pressure. Okay. At the very same time, अगर मैं solvent के amount को बढ़ा दूं, volatile solvent के amount को बढ़ा दूं, solute को कम करूं या फिर volatile solvent को मैं बढ़ाता जाऊं, तो solvent बढ़ाओगे, so what will happen? Most of the area will be covered by solvent only, which is volatile. So will I get to see less vapors or will I get to see more vapors? So answer will be, it will be more vapors. More vapors means more vapor pressure. Are you getting this thing? So this, the thing which we are dealing in this layman term, let's formalize it. Okay. Raoult's law says vapor pressure of an ideal solution is directly proportional to the mole fraction of volatile solvent present in it. Means if P is the vapor pressure of solution, so it will be directly proportional to mole fraction of solvent. As we discussed in a layman term, if solvent will be more, if volatile solvent will be more, vapor pressure will be more. Is this thing clear? Okay. You know, whenever we remove the proportionality sign, we get to see a constant. So P will be equals to K X solvent. What is X solvent? It is mole fraction of solvent. Now, for pure liquid, let's say I have pure liquid. Okay. So for pure liquid, can you tell me X solvent will be how much? If I have just one type of thing, that is solvent, so pure liquid X solvent will be equals to 1. And let me tell you, it will be maximum. You can't have more than one mole fraction. Are you getting this thing? So for pure liquid, X solvent will be 1. Let me put it here. So if I put it here, I will get K and it will be into 1. I am putting the maximum value of X, means mole fraction of solvent. So the vapor pressure that I will get will be minimum or maximum. Should I repeat one more time? Okay. मैं यहाँ पे volatile solvent का maximum amount put कर रहा हूँ, तो मुझे जो vapor pressure मिलना चाहिए वो minimum मिलना चाहिए, maximum मिलना चाहिए, वो मुझे मिलना चाहिए maximum. So in that case, I am not writing P as P, I am writing P as P naught. Are you getting this thing? Now what will be the K here? K is coming as P naught. What is P naught? P naught is vapor pressure of pure liquid. Vapor pressure of pure liquid. Now see one more thing. K equals to P naught I have already written. Let me put the value of K here. So what I will get P equals to P naught into mole fraction of solvent. This is our Raoult's law. Are you getting this thing? Means mole vapor pressure of solution. What is P here? Let me write. P is what? P is vapor pressure of solution equals to P naught. What is P naught? Vapor pressure of pure liquid. Let me tell you, it is a constant. Vapor P naught is a constant and X solvent. Is this clear? Very well. Moving forward. Now, let's draw a graph between vapor pressure and mole fraction of solvent. Let's try to draw this. What is the relation we got? We got P equals to P naught mole fraction of solvent. Can you see? It is Y, it is M, and it is C. Are you getting this thing? Y equals to mx, sorry, it is not c, it is x. So it is a graph of y equals to mx. Let's say this. It will be passing through origin and a straight line. But it will go up to x equals to 1. Don't stretch it up to infinite. It will go up to x equals to 1. Why? Maximum value of mole fraction of solvent is 1. इसको बहुत एकदम लास्ट तक नहीं इसलिए चले जाना है. क्यों? क्योंकि भैया मोल फ्रैक्शन की जो मैक्सिमम वैल्यू दैट कुड बी जस्ट 1. अच्छा आप देखिए, अगर मोल फ्रैक्शन की वैल्यू 1 है, so can you tell me what is this? Can you tell me this value? Here x is equals to 1. If I put x equals to 1, so what I will get as p? P will be p naught. This is the graph between vapor pressure of a solution and mole fraction of solvent. Okay, let's move forward. Now, let's solve a very easy problem. Problem is 1 mole of glucose, we have added it into 90 gram of water, and they are asking us to find the vapor pressure of solution. What they have given us? They have given P naught of water equals to 300 mm of Hg. How will we solve this problem? Let me see. We have a formula. Vapor pressure P is equals to P naught into mole fraction of solvent. Here solvent is what? Water. We have discussed about the solvent. You know, glucose will be volatile or non-volatile? Glucose will be non-volatile. So, I am writing here mole fraction of H2O. How will we calculate mole fraction of H2O? We will calculate as, tell me, mole fraction of H2O will be written as moles of H2O divided by moles of H2O plus moles of glucose. So it will come as 90 upon 18. Are you getting this? 90 upon 18. 90 is the weight of H2O divided by 18. 18 is molecular mass of H2O divided by 90 upon 18 plus 1. So how much it is coming? 18 5s are 95 by 5 plus 1, that is 6. Okay. Now I am putting the value of H2O here. So P naught is given to me, it is 300 multiplied by 5 by 6. So it will come as you can see, 6, 5, 50 times it will be cancelled out. It will come as 250 mm of Hg. This is the value of vapor pressure. Are you getting the same? Okay, let's move forward. Now, let's discuss a case where we have a binary solution formed by two volatile liquids A and B. Those two liquids have mole fraction XA and XB in liquid state. Means, suppose if I have a vessel, what I have done here, I have taken two liquids here, liquid A and liquid B. Both are volatile. None of these two is non-volatile. Okay. What I have taken here mole fraction of A is XA and mole fraction of B is XP. What is this? This is mole fraction. This is mole fraction. One more thing I have done here. Let's say A has P naught A. What is P naught A? Vapor pressure of A in pure state. And what is P naught B? Vapor pressure of B in pure state. But since I have a solution, so none of these two are in pure form. Okay, दोनों में कोई भी pure form में नहीं है. P naught एक pure A का vapor pressure है, अलग कहीं हम लोग calculate कर लेंगे. We'll calculate P naught B separately for B. Now think about this. Since both the liquids are volatile, so will they produce vapor? Yes, they will produce vapor. Will equilibrium arrive? Yes, equilibrium will arrive. Now tell me one thing. These vapor contains only A or only B or both. So correct answer will be vapor will contain A as well as B. यहाँ दोनों ही type के vapor होंगे, A and B. कितने होंगे? We don't care. We don't care about what amount of A or B will be there. We are just thinking if both type of vapor will be there. Okay. Let's say if I have vapor pressure due to A is PA and what is B is creating pressure PB. What PA and PB are? PA and PB are vapor pressure of A and B respectively. I don't know what is the actual pressure is there. I'm just saying if PA and PB are the vapor pressure of A and B. So here PA and Pb. Are you getting this? Okay, let me repeat one more time this entire scenario. I have a box in which I have kept two liquids, both are volatile, A and B. Due to volatile nature, vapors will be formed, not only for A or B, it will be formed for both. Both type of vapors will be there. Both vapors will exert vapor pressure. Let's say A is exerting PA and B is exerting PB. In the liquid state, I have vapor pressure of, mole fraction of A as XA and mole fraction of B as XB. Are you getting this thing? This XA and XB has nothing to do with A and B of this vapors. Are you getting this thing? So XA, XB, I hope terms are clear. Very well. If I want to calculate just PA, so how will I calculate PA? PA will be equals to P naught A into XA. Are you getting this thing? How I wrote this? I wrote this from Raoult's law. Raoult's law according, I can write this. Similarly, how can I write PB? PB will be equals to P naught B into XB. P naught B into XB. How did I write this? According to Raoult's law. Now, what will be the total vapor pressure? Total vapor pressure PT will be equals to PA plus PB. PA plus PB. How much it will be coming as? It will be coming as P naught A into XA plus P naught B into XB. Are you getting this? Now, I hope you know that XA plus XB. Can you tell me what will be the value of XA plus XB? Means sum of mole fraction of your substance. बताइए कितना होगा? Mole fraction का summation कितना होता है? 1. So XA plus XB equals to 1. So at any time you can put XA in terms of XB. Whenever you want. So let's put XA in terms of XB. Oh no, XB in terms of XA. So I can write here XB equals to 1 minus XA. It's up to you. If you want to put XA in terms of XB, no problem. So what I will get is PT. PT will be written as, let me put it here. Firstly, I will write P naught A into XA plus I will write P naught B, and instead of XB I am writing 1 minus XA. So what I will be getting here, PT equals to, if you can visualize it properly, I am writing here P naught A minus P naught B multiplied by XA plus P naught B. Is this thing clear to us? Okay. If we had put XA in terms of XB, slight difference will be there. Okay. I have derived just this relation. It has no sense. It is up to here. Up to this relation we have got sense. Up to this. Let's say this equation is 1. Okay. Moving forward. Now, let's draw a graph between vapor pressure and mole fraction. See, hopefully you can see this. XA plus XB is equals to 1. Means, so XB will increase in this direction. भाई of course ही बात है, अगर XA इधर बढ़ेगा, if XA will increase, so XB will decrease, and if XB will increase, so XA will decrease. So in this direction I am writing XA is increasing, that is why I have written arrow mark like this, and in this direction XB is increasing. Are you getting this thing? Let's say this is 1. Here XA is equals to 1, so XB will be equals to how much? 0. Okay, and here XA is equals to 0, so XB will be equals to 1. Is this clear? So here we have to draw graph between total vapor pressure and your mole fraction. Okay, for drawing this graph, let's consider two things. Let's consider two cases where A is separately present and B is separately present. Do you remember the earlier graph we drew? Which type of graph we drew? We drew the graph between vapor pressure and mole fraction of solvent. We do it like this, no? And here what was the value of X? It was 1. We have already drawn such graph. Okay. So इसी तरीके से what we will do now, we will, although we are having both the liquid simultaneously, but we will try to draw a graph considering that they both are separate. मतलब भले ही हमारे पास दो अलग अलग लिक्विड हैं, दोनों लिक्विड एक साथ प्रेजेंट है, पर हम कुछ ऐसा ग्राफ बनाते हैं इस डेस्क बोर्ड पे कि चलो एक बार सिर्फ एक ए ही प्रेजेंट है और एक बार सिर्फ बी ही प्रेजेंट है। ओके, तो चलो यहां पर मैं ग्राफ बनाने जा रहा हूं। सबसे पहले पी और पी नॉट ए इंटू एक्स है। कैसे ग्राफ बनाऊंगा? मैं मान लूंगा कि ये है ही नहीं। आई विल assume that this is absent. Are you getting this? So if I assume this is absent, so which type of graph I will get? I will get this type of graph, means like this. But remember, up to x equals to 1, don't go beyond that. Are you getting this? This is the graph. What is this graph? This graph is PA equals to P naught A into XA. Okay, straight line. Now, one more graph I want to draw, but this time P versus XA P naught B into XB. Means अब मैं मान रहा हूं कि मेरे पास A है ही नहीं, A है ही नहीं। तो अगर A नहीं है तो ग्राफ कैसे बनेगा? फिर से इस तरीके से आएगा, ग्राफ फिर से इसी तरीके का आएगा। But see, this time I have assumed XB 0 here. I have assumed XB 0 here. So graph will become like this. Because I'm assuming now XB is increasing in this direction. Okay, let me write some values. This will be P naught A and this will be P naught B. I hope you are getting this. This graph, this straight line belongs to PB equals to P naught B into XB. And this graph belongs to PA equals to P naught A into XA. I have made two separate graphs for both the liquid. But think about this. Do we have separate A and B? क्या हमारे पास A और B अलग अलग हैं? नहीं, हमारे पास तो दोनों साथ ही में, हमारे पास दोनों साथ ही में। तो अगर हमें ग्राफ बनाना है कि जिसमें हमारा दोनों का समेशन आ जाए, we want the summation of these two, isn't it? Okay, so think about this. Firstly, graph will be straight line or graph will be curved? Graph will be straight line. It should be straight line because this equation seems to be linear to me. ये इक्वेशन लीनियर दिख रही है तो ग्राफ स्ट्रेट लाइन होनी चाहिए। ठीक, एक बार P नॉट B हो गया, एक बार X B हो गया 1 और X A हो गया 0, एक बार X A हो गया 1 और X B हो गया 0। अगर आपको दोनों को ग्राफ को ऐड करना है तो अच्छा चलो मैं एक क्वेश्चन पूछता हूँ। If I have 7 and if I am adding 2 in it, so 7 और 2 का समेशन 7 और 2 से ज्यादा आएगा कम आएगा? It will be definitely more than 7 or 2 individually. Okay, means if I'm adding two graph, so at any point resultant, see, let's consider this point. So what is this? This is pressure due to A, and at the very same point, what is this? It is pressure due to B. But total pressure will definitely be greater than this and this. So if I add these two, you know, total pressure will come somewhere like this. This is here pressure because of A, इतना pressure because of A से, इतना pressure because of B से। तो अगर मैं इनको ऐड करूंगा सेम पॉइंट पे तो टोटल प्रेशर पक्का बेटा इन दोनों से तो ज्यादा ही आएगा। Are you getting this thing? Similarly, अगर मैं इस पॉइंट की बात करूं, if I talk about this point, what is this? This is pressure due to B. What is this? This is pressure due to A. तो अगर मैं सम करूंगा so total pressure will definitely be greater than any of these two. Let's say it is coming here. So if I keep joining these points, I will get a graph like this. Are you getting this? Means again a straight line. And this graph belongs to PT equals to P naught A into XA plus P naught B into XP. Are you getting this? I am repeating one more time. At any point, if you consider the vapor pressure, let's say here, at this concentration or this mole fraction, here P naught, it is PA, PA will be let's say 5, let's say it is 5. So here PB, as you can see, it is somewhat like 15. So total should be 15 plus 5, that is 20. So this point will be corresponding to 20. Similarly, I added all the points, I got this graph. Okay. Is this thing clear to us? How we do the graph? Okay. Moving forward. Now, we have to discuss composition of vapor phase. Okay. कि हमें पता करना है कि what will be the composition of our vapors formed. Okay. Let's consider the very same case which we are discussing right now. A and B both volatile. XA mole fraction, XB mole fraction in which phase? Liquid phase. Vapors will be formed. Vapor will contain vapors of A as well as vapor of B. Now let's say A has mole fraction Ya and B has mole fraction Yb. Where? In vapor phase. Pa and Pb are the vapor pressure of A and B. Okay, should I repeat? अगेन देख लीजिए, हमारे पास में एक बॉक्स है जिसमें हमारे पास में वोलेटाइल लिक्विड है, ए और बी, एक्स ए एक्स बी उनके वेपर लिक्विड फेज में मोल फ्रैक्शन है, वाई और वाई बी उनके वेपर फेज में मोल फ्रैक्शन है. एक्स ए और एक्स बी का वाई और वाई बी से कोई डायरेक्ट ऐसा रिलेशन नहीं है. नाउ लेट्स ट्राई टू एस्टैब्लिश वन. ओके, सो टेल मी, आई होप यू रिमेंबर दिस. Dalton's law of partial pressure. Do you remember this? What it says the pressure due to a gas A will be equals to total pressure multiplied by its mole fraction. Are you getting this? Let's say the total pressure is 100 and mole fraction of A is half. So pressure due to A will be 100 into half. Okay, this is your Dalton's law. If I write the same x, Pa and Pb as per my Dalton's law, so how can I write? I will write Pa equals to Pt into Ya. What is Ya? Ya is mole fraction of A in vapor phase. So here what I will get? I will get Ya is equals to Pa upon Pt. And what will be the value of Pa? Pa will be P naught A into Xa divided by Pt. What will be Pt? Pt will be P naught A into Xa plus P naught B into Xb. ये कहां से मैंने लिख दिया? From where I am writing this? I am writing these two from Raoult's law. Are you getting this? So mole fraction of A in vapor phase will come as this, and mole fraction of B in vapor phase will come as how much? It will come as Pb upon Pt. Pb upon Pt. Now what is Pb? Pb is what? Pb is P naught B into Xb divided by P naught A into Xa plus P naught B into Xb. This is your Yb. I hope it is clear to you. Okay, let's move forward. Now let's move to limitation of Raoult's law. So there are very few limitations of Raoult's law. The first one is it is valid for ideal solution only. It is valid for ideal solution only. What is ideal solution? We will deal that later. Okay, the first is it is valid for ideal solution only. Secondly, it is valid for dilute solutions only. Means it will not be valid for a highly concentrated solution or concentrated solution. Okay. Third, it will be valid for non-volatile solute only. It will be valid for non-volatile solute only. And fourth, it will be valid when solute neither dissociates or associates. Means okay, if solute is getting dissociate in our solution, means just let's say NaCl. What NaCl does? If you add NaCl in water, it dissociates. Okay, and neither dissociates nor associates. Means it should not be like you added 2 moles of solute and somehow something happened and they started sticking together and now 2 became 1. It should not be like that. Means if you add 1 mole of solute, so it should neither decompose or it should not be associated. Okay, so these are the limitation of Raoult's law. Okay, so by this time we have discussed the theoretical portion of Raoult's law, in which we saw if we add non-volatile solute, so how vapor pressure will change. We drew the graph. We also took an application of Raoult's law. We took a solution of 2 volatile liquids. We took the solution of 2 volatile liquids and we saw how A and B 2 volatile liquid can generate vapors and how can we find the mole fraction. Raoult's law and Dalton's law go hand to hand. these are complementary of each other. Means it's not like you can apply only Raoult's law, Dalton's law will not be applicable. No, both the laws will be applicable, but Raoult's law is applicable in liquid state and Dalton's law is applicable in gaseous state. तो अगर आपको gaseous state में काम करना है तो you go for Dalton's law. If you have to work in liquid state, you go for Raoult's law. Okay. In the next video, we will be discussing about the problems based upon this. Let me tell you, very interesting problems can be formed in based upon this Raoult's law. Okay.